You are welcome to the GMAETS 41's live class. I hope you had a wonderful day. So in this class, we're going to deal with elementary mathematics 2, elementary maths 2. In elementary math 1, math 101, that's in first semester, you treated some concepts like set, polynomial, partial fraction, and the rest of them that was during your first semester. I believe that you guys in UNIZIK, University of Abuja, and some other students, who have run it up their first semester, you're actually taking your break now. But as usual, GMAETS 41 has arrangements to see that we keep students a bit active even while they are on break, so that at least they can prepare for what is ahead as you return for your second semester. So today we chose to kick off in our preparatory classes, the GMAETS 41's preparatory class ahead of resumption. And so I want to use this opportunity to once again say welcome to the class. If you join the class and you can hear me, please indicate I can hear. Type I can hear so that we kick off this class. We'll be looking at relation and functions. Relation and functions. Functions is also known as mapping. Functions is also known as what? Mapping. So please, if you join the class and you can hear me, indicate I can hear so that I kick off the class. All right. Is the online class for JAMB students? Well, quite likely no, but JAMB students can also benefit from it. However, this class is geared towards advanced level students, okay? Those in 100 level, those in 200 level, in various schools. Of course, those in other higher level can learn from this because, it doesn't, even in 300 level, it's possible for a particular course to contain the concept of mapping. All right, Chinyere, you're welcome to the class. I hope you are enjoying your class. You're enjoying your break anyway, not class, you're enjoying your break. Okay, thank you for indicating that you can hear me. I can see 16 other persons connected to the class. Okay, so since somebody has indicated that she can hear me, I think I've got to kick off straight on. We don't have time. We are going to, this is just like a preparatory class, so no much stress like that which you underwent during the exam revision first semester. Okay, like I told you, when you start your learning early, you will enjoy because it's just going to be progressive gradually. And that's the way learning should be. Learning is a process, it's an art. So make sure you connect, stay tuned always to the GMAETS 41 so that gradually you'll be taught. And then you'll understand this very well. Like I said, when I shared the broadcast about this class, if you follow up with this class, right? By the time you would resume, it's going to be a revision for you. When you have your lectures, you won't have challenges understanding what you're going to be taught. If you're just connecting to this class, subscribe right away to GMAETS 41's channel. Turn on the notification bell so that whenever I upload any new content or I am hosting a live class like this, you will be notified. I also want to use the opportunity to inform you guys that for this second semester we are preparing for, GMAETS 41 will be running a question and answer section. Also, I will host a live class where that class will not be for me to just come and teach, rather to take your questions and then attend to those questions if need be on the board. If it is something that requires explanation, I will give an explanation. And before this week ends, I have a wonderful announcement. I'm going to make, all right? Something very wonderful is coming from GMAETS 41 for the best students that are going to ace first class, all right? The overall best in this 100 level on the GMAETS 41's platform, because these ones are going to make it to the GMAETS 41's Hall of Fame. Something wonderful, a package is coming for you people. So you want to work hard so you can be able to beat the record. This is just something that is starting up new on the GMAETS 41's platform. I'm not going to expose it yet because it is not in this class I want to make this announcement. The announcement is going to be special, but it's something that the student that make it to the GMAETS Hall of Fame for this set is going to benefit maximally from, okay? So stay tuned, please, okay? Stay tuned, like I said. Share these links. Share these links to your friends. Invite them to join the class so that you can benefit. Let's move on, please. In your elementary maths 2, maths 102, the topics you're going to deal with, they are not so much, so many as that which you met in maths 101. However, remember that when you have a rundown of a course outline, with each topic, you have the things that you're expected to learn. Is that okay? Now, I'm going to give you a highlight of the topics you're going to meet in this course while you wait for resumption to get further information if there is any addition. But prior to this time, what we used to know as we know. In Math 102, especially those in Unizik, you're going to deal with relations and function, which is the topic you have on the board. Under it, you have the subtopics you're going to treat. As we kick off this topic, I'll highlight the subtopics in there. Then you have limit of a function, that is topic 2. Limit of a function. You have differentiation, topic 3. Like I said, in each topic, you have the steps you're going to deal with them, subtopic. You have integration, topic 4. You have the subtopic on it also. You have coordinate geometry, topic 5. Coordinate geometry, topic 5. You have the various things you're going to deal with on them. And then you have your conic section. Conic section in it, you have circles, you have parabola, you have ellipse, and you have hyperbola. They make up conic section. So there are about 6 main topics. But in each of these 6 topics, you have various subtopics you're going to treat. So the course on its own is a bit elaborate, but not as much as that of Math 101. And like some of you may have known, this course, all right, we liken it to calculus. But remember, like GMAETS 41 has always maintained, calculus is 1 plus 1. I want to assure you this and tell you that on the GMAETS 41's Math 102 playlist, Math 101/Math 102 playlist, all these topics, their subtopics have been treated. The video lessons are available now, fully on the GMAETS 41's platform. Okay? So you are on the platform of complete embodiment of academic work. Like I said, the GMAETS 41's academic firepower is on high alert, and from today has been unleashed. So we shall be looking at relation. We are going to define this term, relation. We are going to define function, also known as mapping. Are you following right? Mapping. We are going to look at the concept of domain. We are going to talk about codomain. Codomain. We are going to look at the concept of image. I'm trying to give subtopics, various things you are meant to learn under relations and functions. We are going to talk about range. For today's class, we'll focus on this. We'll focus on this. Right? A little touch on this, 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 if need be. But the part 2 of these thoughts, we won't cover it in this class because, like I said, as we kick off this preparatory class, there will be no pressure. 30 minutes, 1 hour, likely 1 hour, 30 minutes at most, we are done. Now, after this, we have the concept of, I've talked about range. We have the concept of composite functions. Composite functions, you're going to deal with it under relation and functions. We are going to talk about asymptotes. Asymptote. Asymptote. We're going to talk about step function, step or piecewise function. Step or piecewise function. So by the time you're done with all of this stuff, you've covered this topic, the things you're meant to know. Of course, within this concept of function, we are going to be talking about one-to-one type of function. We're going to be talking about the onto function. We are going to be talking about the one-to-one and onto function. That is where you talk about invertible, right? And the rest of them. But don't worry, like I said, we're going to deal with all these things as we move on in this course. We are looking at relation and functions. I've highlighted the major things you learn under relations and functions. I don't think there is anything missing. I've told you already that within this concept of function, we have the one-to-one, the onto function, and the one-to-one and onto function. Okay. Invertible, injectable, right? But don't worry, we'll deal with all of those. Today, we will look at the concept of relation. We'll talk about function. Then within it, we'll look at one aspect, okay? Part one aspect of domain, codomain, image, and range. Let's define what relation is. What is a relation? A relation is defined as the subset of the Cartesian product of A cross B. A relation is defined as a subset of the Cartesian product of A cross B. Now, usually we could hear this term, a relation from a set A to a set B. Because whenever you are talking about relation, just like we know in human relationship, okay, you connect two or more things. But here we are looking at a connection between two things, where those things, we call them set. Good enough, in your Math 101, elementary Math 1, you have learned the concept of set and subset, right? So if I have set A and set B, we try to find the relationship, the relation between A and B. So we define relation from a non-empty set A to another non-empty set B as the Cartesian product of A cross B. That is simply what a relation is. A relation from set A to set B, where both sets are non-empty sets, is a subset of the Cartesian product of A cross B. All right. So having defined that, maybe I could write on the board, relation from, let us use R to represent relation. Relation R from a non-empty set, A to another non-empty set. Non-empty set B is a subset of the Cartesian product A cross B. So when you consider two non-empty sets, A and B, and then you are defining relation. Relation is simply a subset of that Cartesian product A and A cross what? B. A relation is simply what? A subset of the Cartesian product of these two non-empty sets. Now, when we talk about A, what is A in this definition? I hope this has not cut off from view. All right, it's showing. This A is called the domain. A is called the domain. Then B as a whole is called the codomain. B is called the codomain, B as a whole. What usually happens whenever you are studying mapping is that you try to find the relationship between A and B, whereby you look at a situation whereby A produces some elements in B or all the elements in B. Once again, you are dealing with relation. You try to consider, two subsets, one called the domain, the other called the codomain, whereby you are drawing a relationship between A and B such that A produces either some of the elements of B or all the elements of B. This is set A. This is set B. I repeat that once again. You check the relationship whereby A produces what? Some elements in B or all the elements in B. All the elements in B together, the set is called codomain. The set is called what? Codomain. So this is just the concept of relation. However, I want to say this quickly, that in dealing with relation and functions, our emphasis most especially is placed on functions, which is mapping. Our emphasis is placed on what? Functions, which is mapping. I have told you already that the elements in A, they produce the elements in B. Those elements in B that A produces are called image. Those elements in B that A produces are called what? Image. Now, when you form a set using the image inside this codomain, when you form a set using the image that are obtained inside what? The codomain, that set you form using the image is called the range. So you see the connection there. Relationship between A and B, where A, set A produces set what? B, because the elements in set A are used to obtain the elements in set B. Now, those elements in set B that the element in A produces or produce, we have a name we give to them. A, set A alone is called codomain. Set B, set A alone rather is called domain. Set A alone is called what? Domain. Set B as a whole is called codomain. And like I said, the element in set A can produce either some or all the elements in the codomain. I repeat that again. The element in set A can produce some or all the elements in set B, which means that domain, which is set A, as you are referring to, you can use X to represent it also. Domain produces what? Codomain. Domain can produce some elements in the codomain, or domain can produce all the elements in the codomain. I hope you understand this concept of A and B called domain and codomain. Now we are talking about some elements in the codomain that some of the elements can be produced by the domain, or all the elements in the codomain can be produced by the domain. In either case, whether it is some of the elements that are produced or all the elements in the codomain that are produced, whatever you have inside the codomain is called image. Whatever you have inside the codomain that is produced by the domain, I repeat that again, take note. Whatever element you have inside the codomain which exists as a result of being created or being produced by the domain, those elements in codomain produced by the domain, they are called the image. They are called what? The image. Now, if you use the image to form a set, to form a set, you must have these brace brackets. You must have these brace brackets. If you use the image to form a set, once the image forms a set, the set of the image is now called the range. The set of the image is now called what? The range. So that's just the whole concept about what relation is with respect to giving us domain, codomain, image, and range. I want you to quickly take a look at this. Imagine that I gave you something like this, and I gave you this. Then I draw something of this kind, say that this is a relation. I'm assuming. So we have this as A, we have this as B. And we now say that we have 1, 2, 3, and then we have 5, 6, let's say 4, 8. Let us now say that I link this 1 to 5, which means that 1 produces 5. I link this 2 to 6. Let me wipe this 8. And I link this 4, this 3 to 4, which means 3 produces 4. Okay, let me have this number here, 7. And then I link this 7 to 6. Or let me even refuse to link. I decide not to link. It's my choice, because here I'm defining relation, not function yet. I'm defining relation, not function. Now notice something. 1 produces 5. So 5 is the image of 1. But before I move on into explaining that concept, A is domain, B is codomain. This range you are seeing here, range, R. I'm using that R to this relation rather, not range. The relation you are seeing here, R, I'm using R to represent the relation. Links A to B. 1 produces 5. This A is our domain. Let me indicate it. Everything you have in B is your codomain. You know why I'm taking my time in this stuff is if you understand the background of relation, function, it helps you to understand everything you are doing in this topic, every other thing. So the startup is very important that the student grasps the whole idea as much as possible. Otherwise, going further, what you'll be doing wouldn't be making sense to you. Now, this A is domain, this B is codomain. You notice that 1 is linked to 5, which means that 1 from the domain produced 5 in the codomain. Therefore, 5 is image of 1. It's just like somebody giving you an equation, y is equal to, let us say x plus 4, x plus 4. And I tell you that if x is equal to 1, if x is equal to 1, what will it produce for y? If x is equal to 1, it will produce a value for y, and that value of y will be 1 plus 4, which is equal to 5. So we can conclude that 1 gave birth to 5. Therefore, 5 is the image of 1. I'm trying to make you understand this concept. 5 is the image of 1. That is what we have here in this case. I just assumed an equation. I'm not saying that this equation defines this relation. That's not what I'm saying. I've just brought this out to like try to help you understand this concept. If you fix 2 here even, you would see that you're going to get 6. But please don't go further. Don't go further, because if you fix 3 here, you won't get 4. But remember, I'm still trying to interpret the concept of all these domain, codomain, image, range as used in relation. We're still coming to function where we'll deal with it even more, because your main work in Math 102 under relation and function focuses more on function. All right, let's move on. 1 produces 5, so 5 is the image of 1. 2 from the domain produced 6 in the codomain. So 6 is the image of 2. 3 in the domain produced 4 in the codomain. So 4 is the image of 3. Now, dear friends, calm down. Remember I told you that what I showed on the board here, this diagram is relation. I didn't tell you it is function. I said it is what? Relation. I have never called this a function. I am emphasizing on this because, dear friends, functions and relations are not exactly the same. By the time I am done with this and we are entering function, one of the key things I would like you to bear in mind before we move on into it is that all functions are relations, but not all relations are functions. So that any one of you there who maybe have an idea of this, and then you are wondering, no, this thing is wrong and this, calm down, it's not wrong. This is not a function, it's a relation. That is why in this case you have 7 in the domain, but the 7 did not produce anything in the codomain. It is still a relation because it's trying to link the domain to the codomain, elements in the domain to the element in the codomain. That's just what relation does. Is that okay? If it were to be a function, there is no way this 7 will be left out like that. There is no way. All right. So now, from what I interpreted here, and based on what I really want you to know about the aspect we are covering today, already you know that our domain is 1, 2, 3, 7. That's the domain. In case of this, let me just bring it here. As in this case, the domain is this set of this element. You must use the set symbol. You must use the set symbol, this brace bracket. So we have 1, 2, 3, 7. This is the set called the domain with respect to this relation. Let's look at the codomain. The codomain here, we've got 5, 6, and 4. Now look at the image. The image includes 5, 6, and 4. Do you notice a difference now? For the image, I did not form a set for it. Because normally when you are dealing with image, it's not a set. I can just ask you what is the image of 1 here, and you will tell me that in 1, this in means image. Image of 1 equals 5, just like that. If I ask you what is the image of 3, for example, you will tell me in 3 is equal to, if you check, the image of 3 here is 4. In 3 is equal to 4. So for image, we don't enclose it in brace bracket. It is not a set. Coming to the range now. Coming to the range, like I told you, the range is obtained from the set of the image. So the range will be 5, 6, and 4. That's just the concept of domain, codomain, image, and range. Take note, please, that it is possible for you to still have an element here, and this 7 will not be there. Let me assume that I fix 7 here, and then there is no 7 here. Something of this kind. No 7 here, but you have 7 in the codomain. Again, that is going to be a relation. That is going to be a relation, but not a function, right? Okay, it's going to be a relation, and it will also be a function. And in this case now, 1, 2, 3, 5, 6, 4, 7. Even though there is no mapping to these 7, nothing produced this 7 from the domain, we can still call this a function. Don't worry, we are going to learn about the condition of function. Okay. So in this form, this is still a relation. This is still a relation. And you can obtain the domain, the codomain, the image, and the range. For example, in this format, I'm going to bring back what I have. But permit me that we close this 7. Looking at this, what is the domain of this relation? And like I said, this relation you are seeing here in this form is a function. But don't bother yourself. You will learn about function as we move on. The domain is all these elements, the set of the elements A, which include 1, 2, 3. So the domain still remains, okay, the domain will be 1, 2, 3 without 7 there, which means I'm going to remove this 7. If at all, there is no 7 here. Then what will be the codomain? The codomain will be all the elements in set B, 5, 6, 4, 7. Which means in that case, as I remove the 7 from here, I am going to include the 7 here because you are seeing 7 in the codomain. What is going to be the image? In this form, as you are seeing here, dear friends, the image will remain unchanged. The image will be 5, 6, 4. 7 will not be included. If you look at the image and range, you agree with me that the image and range, we get them from the codomain. But you see, although I have removed 7 from the domain, I introduced 7 in the codomain, but I'm telling you that in this case, the image will not change. Remember, in this form that this relation took here, the codomain changed, the domain changed. Why? In the domain, there is no 7. So there is a change there. In the codomain, now 7 entered. Different from the first thing you had in the first diagram before I cover the 7. But in this form, even though I have changed this relation a bit, the image still remains the same in this case. Why? Because whenever you are talking about image, image must be an element in the codomain that is created, that is produced by an element in the domain. Image must be an element created, produced by an element in the domain, which means you cannot have an element in the codomain just like that without being produced by an element in the domain, and you call that thing an image. It's not possible. Like in this case, this 7 is not an image of anything in the domain because nothing from the domain produced this 7. That is why in this case the image will remain the same, 5, 6, 4, because 5, 6, 4 are produced by 1, 2, 3. 7 was not produced by any element in the domain. Therefore, 7 cannot be part of this image. The image still remains unchanged, 5, 6, and 4. And since the image remained unchanged, the range will also remain unchanged because the range is simply the set of the image. All right, let's go back to what we had earlier. I want to believe you get the concept of relation, domain, codomain, and at least to an extent, image and range. Those are very clear concepts already. My battery is very low. Will this video still be accessible tomorrow, sir? Yes. Whenever GMAETS 41 is done with a particular class, a copy of that video is always made available. All right, we are moving on. Daily clips. Please do acid-base review tomorrow, please. I won't do it. We have already reviewed acid, base, and salt. If you check on the live session of the GMAETS 41's channel, this particular channel, go to the live session, search through, you will see a live class already being conducted, all right, on acid, base, and salt. So let us move on, please. I've established the concept of relation, so we are going to move on to function. We're going to move on to functions. Let me wipe this. Let us start by first defining what a function is. Function. Let's define what a function is, okay? I'll still leave this for a moment. What is a function? A function, which generally we write it in this format, said f is such that, okay, permit me to use x and y. This means a function such that x is mapped, is linked to y. A function such that x is mapped to y. Remember, function is also known as mapping. So the way we read this is f is such that, that is a function such that x is mapped to y. In this case, x is the domain, just like A there. Are you following, right? And y is the codomain, just like B in this case. So let's define a function. A function is defined as a relation. Did you take note of that? A function is defined as what? A relation, which simply means that all functions are relation, like I said, but not all relations are function. A function is defined as a relation which assigns, which gives each x, which gives each element of x a unique element y. I define it again. A function is defined as a relation which assigns to each element x a unique element y. I know the elements, they belong to a set. So what the function will do is to assign to each element in set x. It will assign to it. It will give to it like a value. It will give a value to it. And the value is going to give to it is a unique element from set y. I'm going to write the definition on the board. A function or mapping is defined as a relation which assigns, and that assignment means to give a value to something, which assigns to each x element of set x. You know, I told you this element x belongs to a set called x, and that set called x is domain. So a function will assign to each x, which is an element of set x, a unique element y, which is element of set y. Do you remember when I did something like let y be equal to x plus, think x plus 4, I guess, and then I say if x is equal to 1, you find out that y in this equation, this function here now, let's just call it this relation or whatever, will now be equal to 1 plus 4, which is 5. So did you notice that 5 has been assigned? 5 has been assigned to what? To 1. 5 has been assigned to 1, which means that 5 is a value given to 1. This is what a function will do for you. A function will assign to each element in the domain. A function will assign to read an element from the codomain. Like in this case, maybe let me draw another one on the board. I have this, and I call this a function. Let us say we have 1, 2, and 3. Let's have 2. Okay, let's have use a different symbol. 10, 15, 16. Let's say 20. And then I link up 1 to 10. This is set x. This is set y. And we call that set x the domain, set y the codomain. Now, what a function will do is to assign to each of these elements in the domain. It will assign to it a value, a unique number, a unique value from the codomain. So in this case, 10 has been assigned to 1. I could do something like this. 16 has been assigned to 2. I could do something like this. 20 has been assigned to 3. For function, everything in the domain must have an assignment. Everything in the domain, if you are talking about function, which is something that is different from relation. For function, every element in the domain must be mapped. Every element in the domain must be assigned to something in the codomain. Every element in the domain must have an image in the codomain. That is one unique difference between function and talking of relation generally. Because in relation, it is possible for you to have an element in the domain which does not have any image in codomain, which does not produce anything in the codomain. It's possible for relation, because relation is just an open something. That is why when we are defining it, to say it is the Cartesian product of A cross B, all of them put together, linked up, without minding whether it produced an image or not. But for function, every element in the domain must be mapped. However, it is not compulsory. It is not compulsory that everything in the codomain must be an image. No, it is not compulsory. It is not compulsory that everything in the codomain must be an image. No. That is why when I was actually defining relation and then giving further explanation to that definition, although I was talking about relation, but I used one statement. I told you that the element in the domain can produce some or all the elements in the codomain. I said something like that. Domain can produce what? Some or all. In this case now, the domain produced some. For example, 1 as a domain produced 10. 2 as a domain produced 16. 3 as a domain produced 20. This is some, because you can see that 15 does not have any linkage there. So the domain just produced some. Are you following, right? Some of the elements in the codomain. But even at that, this diagram you are seeing here on the board is a function. This relation you are seeing is a function. All right. Now, I've given you the concept of what a function is, and you've seen it with a definition on the board. The time has come for us to differentiate clearly between function and relation. The time has come for us to differentiate clearly between function and what? Relation. After that, we are going to look at some past questions. In Math 102, no time. The GMAETS 41 doesn't waste any time. Like, I believe in one thing. Learning is an art, is a process. And for us to learn very well, we want to learn without undue pressure. You learn without too much pressure. All right. So let us see some statements here. In mathematics, a function from a set X to a set Y, that's from Smokey. Smokey, why are you bearing that name in the first place? I don't understand. Anyway, don't worry, don't mind me, but just an observation. In mathematics, a function from a set X to a set Y assigns to each element of X exactly one element of Y. The set X is called the domain of the function, and the set Y is called the codomain. And that is absolutely correct, Smokey. What you said is true. No argument to that. And of course, that's the definition you still have here on the bar. It is just grammatical usage. And remember, English language will tell you something about passive voice and active voice. The man killed a snake. Active. A snake was killed by the man. Passive. Both are still saying the same thing. Another good reason why, yeah, we know that cramming, memorizing some things. Yeah, to some point, there are certain things we study, we have no choice than to memorize it. However, understanding what you are learning is very important. If you get the understanding, you can actually put the grammar in a way that still explains what you are studying. The whole idea when you are talking about function is that a function will assign, will give values to elements in the domain. And where would the function pick the values? It is assigning, it is giving to the domain. The function will pick those values from the codomain. And did you take note of the term I used here, a unique? Unique, which means that the element in this domain can only be assigned. Like one element in the domain can only be assigned to one element in the codomain. One element in the domain can only be assigned to one element in the codomain. That is what makes it unique. Don't worry, as we move on to the difference between functions and relation, that particular concept will become very much clearer. Are you teaching bijective functions? Yes, but it will not be covered in this class. Like I said, we don't have any examination we are preparing for, at least not for my students in Unizik, not for my students from University of Abuja, right? These ones just finished their first semester exam, and this is just preparatory classes ahead of second semester resumption. And this does not require that we overstress the students that are on holiday now. So the class today will not cover up to injective, bijective, surjective, invertible functions. You know, I mentioned that it's just like you are joining us, but I mentioned that from the beginning of the class. That will not go to that extent. All right. But as the class moves on, we are going to treat all of those. However, on this channel, you know, this is a live class. Pre-recorded videos have already been made on this course and topic. If you go to the GMAT 41's Mat 101/Mat 102 playlist, scroll down, you'll see Mat 102 course outline, courses. Around these things about function, everything has been covered, including the invertible, the surjective you talked about. You know, that surjective, invertible, injective are the concept of one-to-one, onto, and one-to-one and onto function. I hope you know it's just another name for it. Okay, guys, please, let us now look at the difference between functions and relations. I'll give you a moment to finish your words on the board. You can screenshot. I've always said that. You can screenshot. And mind you, this class will not cross 1 hour. It will not cross 1 hour, 30 minutes. It won't cross 1 hour, 30 minutes. I mean it, and my reason is simple. There is nothing at stake. There is no information about my students, all right? In order to become the GMAT 41 student, you have to become a channel member, number one, very important. You also have to send a message to GMAT 41 on this WhatsApp group, on this WhatsApp number rather, this contact. Send a message to that contact on WhatsApp and request kindly to be added to the GMAT 41's general WhatsApp group. Indicate where you are contacting GMAT 41 from. Tell us your name and tell us your level of study, because that will help us to know the group you should belong to. If it is O level, you know, whether grade 10 to 12, or whether it's advanced level, 100 level, 200 level, 300 level, as the case might be, or whether it is basic level of learning, because the GMAT 41 also has a channel dedicated to our basic scholars, those in grade 4, grade 5, grade 6, grade 7, grade 8, grade 9. The GMAT 41's basic class channel, that's the name of the channel, GMAT 41. The GMAT and 41 no space. It's not written like this. Just write GMAT 41 together. Then you space basic, you space class. And you see that channel. You need it for your younger ones anyway, in that level of learning. It's very important for you to join our WhatsApp group so you don't come to my live classes and be asking some questions. You need to follow up and know what is going to be covered, what we are looking at, you know, the day and the times we have classes, when we are hosting live class, when it is expected for students to take pre-recorded video lesson already on this channel. In your school, if you're in class and your teacher is teaching you biology, let's assume they are teaching you nervous system. Do you now start asking questions on cells and its environment, where you talk about diffusion, osmosis, osmotic pressure, plasmolysis, hemolysis? Do you talk about that? So I'd like you guys, please, let's do the right thing. GMAT 41 has his principles. And that's why I've been calling to you guys. Send a message to this WhatsApp group if you want to join this platform fully. If this platform is giving you what you need, so you know the way our lessons are being organized. And you have to become a channel member. Very important. Join us on platinum level or above, platinum or diamond level. Because sometimes the live classes might just be made for members only, and you will miss that. Other times, even this live class, I might be done with it, and the next thing, it will be converted to members only. So to access the video lesson, in order to be free, whether the lesson is meant for members or not, please consider becoming a channel member. All right, join on the platinum or diamond level. Don't join on the gold. If you join on the gold, it's just a way of saying thank you, you're appreciating our work fully, okay? All right, let's write this. Now we want to look at differences between relation and function. Relations and functions. We want to find out the difference. But first of all, before we start, take note. All functions are relations, but not all relations. But not all relations are functions. Take note of that. All functions are relations, but not all relations are functions. How did we know that all functions are relations? Yeah, all functions are relation. You remember in the definition, we define function as a relation. Function or mapping is defined as a relation. So you want to take note of that. All functions are relations, but not all relations are functions. So what are the conditions for a function, for a relation to be considered as a function? What are the conditions for a relation to be considered as what? A function. You would have to take down this as I state the conditions, because I won't write them on the board. Okay? If you want to get a certain note or whatever on it, you can still decide to take it on the GMAETS 41s, Math 101, 102 playlists. I have a video lesson that deals with this particular concept with a note well written on the board. So what are the conditions for a relation to be considered as a function? Number one, which is one of the most important, all the elements in the domain must be mapped. All the elements in the domain must be what? Mapped. Must have an assignment. Must have a value assigned to them. It is not possible for you to have something, an element in the domain that doesn't have an image here. If such a thing happens, then that relation is not a function. So for a relation to be considered as a function, all the elements in the domain must be mapped, must have an assignment, must have an image. So that's condition number one. Then condition number two, another very important. In fact, there are two major conditions for a relation to be a function. I've stated one. The second condition is no single element in the domain, no single element in the domain can be mapped, can be assigned to different elements in the codomain. No single element in the domain can be assigned to different elements in the codomain. Take note, we use the term unique element. You assign to each of the domain a unique element. You assign to each of the domain a unique element from the codomain, which means if you are talking about the unique, you can't have a mix up of numbers, of values, of image. You can't have a mix up of elements in the codomain assigned to one element in the domain. It's not possible. You know, I've been speaking grammar in this condition number two. Look at what I mean by that. If you have something like this, it's not possible. 1, 2, 3, 5, 8, 9. And then you have something like this. Let me say 10. Okay, let me even remove this way. Okay, and then you have something like this. Have something like this. You have something. Okay, I think I have to go more. 9, 10. You have something like this. And then you say that, okay, let me just map this again to this. This last thing I did here, denied this relation from being a function. This diagram you're seeing here is a relation. Is a relation. Relation. Not function. Not function. Let me write it on the place so that you don't confuse it with the rule of thumb given above. This time you are seeing this is X, this is Y, domain and codomain. This is a relation. This is a relation, not a function, not a function. Now one might now ask, why is this not a function? It is not a function because you cannot assign different elements in the codomain to a single element in the domain. Is not possible. If you look at 1 was assigned 5, that same 1 was assigned 10. There is this layman explanation I usually give, just like an example, to help scholars understand why this is not possible. We can take the X, which is the domain, as son, a child. It can be daughter also. And we take Y, the codomain, as we take it as father or mother, parent. Are you getting me right? So we have, let's just go son, father. Or should I use daughter and mother? I used to use son and father, son and father. Let me use daughter and mother this time around. So domain is daughter. Codomain is mother. Imagine you have this daughter, just one person, a daughter, one child, a daughter. And I say that that daughter has 2 biological mothers. That's to say that this daughter was given birth to by this mother 5. That same daughter was again given birth to by mother 10. Biologically, is that possible? DNA would clearly tell you that it is one out of these 2 mothers that gave birth to 1. Right? The paternity of the child will be determined. The maternity, I'm talking about mother now, the maternity would be determined. Out of these 5 and 10, one of them definitely gave birth to this one. So it is not possible in real life for a child to exist and have 2 or more biological father, 2 or more biological mother. A child can have only 1 and 1 biological parent. That is the reason why it is not possible for an element in the domain, which we are taking as a child now, to be mapped, to be assigned, to be linked to different elements in the codomain is not possible. The reason why, again, we use the term unique here, that a function will assign to each element in the domain. It will assign to it a unique element in the codomain. So anytime you see a function, you see a relation, and it happens that one element from domain is assigned to 2 or more different elements in the codomain, please, that is not a function. It is a relation, but not a function. Because following this layman term, explanation I gave, this illustration, that occurrence as a function is not possible. A child cannot have 2 different biological parents. I hope this makes sense. I've given you the 2 basic conditions for a function to be a relation, or for a relation rather to be a function. I've given you the 2 basic conditions for a relation to be what? A function. And I hope you understand that. Quick review. The first condition, all the elements from the domain must be assigned, must have an assignment, must be mapped. That's one condition for a relation to be a function. So this you are seeing is a relation, is also a function. All the elements here were mapped. And if you observe here, no single element in the domain was mapped to different elements in the codomain. So it satisfied the condition of a relation being a function. Condition number 2, a single element, an element from the domain cannot be mapped to different elements, cannot be assigned different elements, different values in the codomain. It is not possible. It is not. But take note, please. What I said is that one element from domain cannot be assigned to different elements in the codomain. The other way around is possible. What is possible in the other way around? Different elements in the domain, different elements in the domain can be assigned to one element in the codomain. That one is possible. That one is possible. Let me show you quickly why that is possible. Look at this. I have something like this, and then I give you 1, 2, 3. I give you 4, 5, and then let us have this assignment. 1 is linked to 5, 2 is linked to 5, 3 is linked to 5. Is this relation a function? The answer is yes. It is true that if you come to the domain, one element in the domain cannot be mapped to different elements in the codomain. However, if you come to the codomain, it is possible for one element in the codomain to be an image of different elements in the domain. And if you use this child-parent relationship, this will make sense. If I take this as the child, let's say the daughters, and here, 2 different mothers. It is possible for a mother to give birth to 2 or more children. That is what played out here. That is what played out here. So what you are seeing here is a function, and it is also what? A relation. It is a function, it is also what? A relation. It is possible in real life for one parent, one mother, right? Yeah. A woman who is married, it's possible for her to give birth to 2 or more children. But it's not possible for a single child to be given birth to by different mothers. No, it's not possible. Biology will always cancel that. Yeah. DNA test will always strike that off. So you take note in case you see something like this. Like this function is called constant function. It means for any value of the domain, you will get a value, a particular value in the codomain. It's possible for us to have such kind of function. And I'm going to show you one quickly. If I define y to be equal to, or maybe I define f of x to be equal to x raised to power minus 2. X raised to power minus 2. If let's say x raised to power minus 2, right? Or let's just say x squared. X squared, yeah. X squared, because this is where the concept of even and odd function comes into play. And like I said, we're going to discuss all of those as we move on in this topic. If x is equal to positive 1 here, you will notice that f of x, which is the value of y will also be 1 in this case. Then look at this. If x is equal to minus 1, if I fix minus 1 here, what is going to be the value of y? Y will still produce 1. So did you notice that this function is constant with minus 1 and plus 1? Because when I used minus 1, I got 1. When I used plus 1, I got 1. If I'm to sketch this function, maybe something like this. I used 1, I used minus 1, and both of them gave me the same value, 1. So if you are assigning, you have something like this. So it is possible. It is possible. This is a function, all right? Is a function. Okay, so you have known the conditions for a relation to be considered as what? A function. You have known the condition for a relation to be considered as what? A function. You're welcome, GovXX country. Thank you for thanking me. You're welcome to joining the class. I believe that this breakdown, this explanation I gave, can now help to be able to identify a relation that is a function, because it's an exam question. An examiner can give you a question with options and then ask you which of the following relation is a function. In fact, we are going to see that as we move on to the next aspect of what we have to deal with. Because the next aspect now is for me to show you how you can write this thing in condensed form. Okay. Most times in CBT exams, you have these equations where all these things are being drawn, diagram with circles. Most times they might write it in condensed form or use mathematical equations. So I'd like you to get used to the condensed form. After that, we take some past question and then we'll close for today. Now, next class, we'll move on to look at domain fully in terms of mathematical equations. All right, then we'll talk about range. We'll be moving on, inverse of a function and the rest. So we'll finish this topic. Like I said, you want to know how our classes are being scheduled? Send a message to this number on WhatsApp. Request to be added to the GMAETS 41's general WhatsApp group. Indicate your name when you're sending that message, where you are contacting GMAETS 41 from, and your level of study, whether it is O-level, high school, or advanced level. Finish up what is on the board here. I'm going to wipe it, and then we would move on to looking at the condensed form of functions. You can screenshot, it's going to help you, okay, to be fast, because I wouldn't be waiting for you to be copying all of this. So if you want to screenshot, you can screenshot. All right, let me wipe this. We want to look at the condensed format of writing all this circular function, notation. This is circular notation, diagrammatic notation of function. We want to look at the condensed form where we use set notation for it. After that, in our next class, we'll look at mathematical equation used or considered as functions. Okay, now consider this function. Consider the function. Please take note that at this point, we are giving full attention to functions now. We are done with anything relation. Relation is not what we study in this topic and in this course. What we study is function. So consider this function. What I intend us to do is to write the condensed form, the set notation form of this guy. So this is a function, and you know that all functions are relations. So what we actually, this topic is relation, but we are just picking, the part of that relation called function. So if you write any function, it is relation that you've actually written. But we're seeing them more as function. So let us say we have -1, 0, 2, 3. And then I have 5, 6, 9, 10. Let us say that I assigned 6 to -1. I assigned 10 to 2. I assigned 5 to 0. And I assigned 9 to 3. If you look at this satisfies all the conditions for a relation to be a function. For example, you notice that all the elements in the domain were marked. All of them have an assignment, a value assigned to them from the codomain. So satisfying one condition of this relation being a function. Then let us look at the second condition, because the two conditions must be satisfied before you conclude that the relation is a function. The second condition is that no single element here was mapped, was linked to different elements in the codomain. If you notice, each element from the domain was assigned to a unique element, to just one element in the codomain. Now, what is the condensed form of this guy? Set notation. The set form. Set form. Set form. It permit me also to write condensed. Condensed. So instead of drawing this diagram, we decide to condense it. So what do? We are going to say that we're going to define this set as maybe A, where A is a relation which is a Cartesian product of these two. So A is a Cartesian product of X and Y. I don't know, how do I differentiate between this cross, then X, Y? This is cross. A is a relation which is the Cartesian product of X and Y, domain and codomain. Remember when I defined relation, and that is equal to, we now have this set. You can either just simply write A equal to this, or X cross Y equal to what I'm about to write. So you write the domain first. You write the element from the domain first, the charge. Now you notice that we have -1, comma. So this -1, the value assigned to it is 6. So this 2 is going to be enclosed in a bracket inside that set. Then we have 0 and 5. Both of them will be enclosed in this curved bracket. Then you notice that we have 2 assigned to 10. 2, 10. And then finally, I hope this has not cut off. I hope it has not cut off. Please let me check the camera so that I know if I can put the second part, the last part. Yeah, I think the last part should enter. The last one is 3 being assigned the value 9. 3,9. So this is a relation. An examiner can give you this relation and then ask you to identify the domain and the codomain. The image, the range, you can be asked to find that. You can also be asked if this relation is a function or not. Is this relation a function or not? You can be asked that. So let us extract certain things. How do I know that this relation is a function? How do I know that this relation is a function? This is what will guide me. I'll start looking at the domain. The domain are all the first element. The first element, -1, 0, 2, 3. Because in that case, you won't see this diagram. Can just expose you to this. And then I ask you, is this relation a function or not? How would you know that it is a function or it is not a function? Quickly, focus on the element of the domain. And the elements of the domain are the first element, -1, 0, 2, and 5. Then check if there is any place that a particular element of the domain was repeated. If there is any place that the particular element of the domain was repeated. For example, you have -1 here. Check if there is any other place you have -1 repeated as element of the domain, or the first element. Or you have 0 here. Check if you have 0 repeated in any of the other parts. Are you following, right? In any of the other domain. If there is no repetition of any element of the domain, as in this case, -1 did not repeat anywhere. 0 did not repeat anywhere. 2 did not repeat anywhere. 3 did not repeat. And answer, that's good. This is a function. This is a function. Because no domain No element of the domain was repeated. However, if there is any place that a particular element of the domain was repeated, what you will do is to check that place that the element of the domain was repeated. Does it have different codomain? Does it have different codomain? If it has different codomain, then that is not a function. Don't worry, we are coming to that. I've just shown you the condensed form of this. Like I said, this is a function. I've told you the reason. There is no codomain, there is no domain element that was repeated. No domain element was repeated. It is possible for codomain to be repeated, no problem. But whereby domain element is repeated, then you want to be careful. Check that it may not be a function. I've written the condensed form of this. Now, what is the domain of this guy? Domain is equal to -1. You can just get it from here. All the first element, 0. Call me the first element here, 2. Call me the first element in this coordinate, 3. So this is the domain. Now, what is the codomain? Codomain are all the second elements. Here, the second element in this coordinate is 6. Second element in this coordinate is 5. Second element in this coordinate is 10. Second element in this coordinate is 9. So these are the elements of the codomain. Of course, you can see it here. If you are asked, what is the range? In this case, the range is equal to the codomain. The range from what I saw here is equal to the codomain. Why? All the elements in this codomain are values, they are images of an element in the domain. So from here, this is also equal to 6, 5, 10, 9. In fact, this function is called one-to-one and onto. One-to-one and onto. Don't worry, we'll talk about that. If you are asked image, the image is simply this element, 6, 5, 10, 9, without that set notation. That is it. I think I've shown you the condensed form of this, of how to present function. In case you see something like this and you're being asked a question on it. Remember why I told you that this is a function. It's a function. Let us look at this one at least. I told you that this guy is not a function. At least I explained why it is not a function. Let's condense this and see the form it will take in set form, in condensed form, that will help us know that this is not a function. So I want to condense this guy here. So it's going to be, let's call it B. Let's call it set B. If you want to write X cross Y, the choice is yours. So this is the relation. The relation, we are calling it set what? B. So all I have to do is to pick these pairs as in coordinate form. So this is going to be 1, 5. 1, 5. Next is 2, 8. Let me go around first. 2, 8. Next is 3, 9. 3, 9. 3, 9. And finally, you notice that 1 was still assigned to something, which is 10. 1, 10. 1, 10. 1, 10. Close the brace. So this is a relation, but let's find out, is it a function? Is it a function? Like I said, quickly look at the element of the what? Domain, which are the first element. Then check, is there any place that a particular domain was repeated? Is there any place that an element, is there any coordinate here that an element in the domain was repeated? If you look at, this is 1 here. As you go across, you notice that that 1 was also repeated here. So I'll just indicate that, 1 was repeated in the domain. And I told that whenever any element of domain is repeated, please watch out for it. That guy might not be a function. What you now have to do is to check the codomains attached to them, the elements of the codomains attached to them. If the elements are different, then that is not a function. Now notice the element attached, the codomain element attached to this one is 5. The codomain element attached to this one is 10. Therefore, this is not a function, because it is as if you have one child, the same child, having different mother or different father, as the case might be. It's not possible. So one was repeated in the domain, but with different codomain value, different assignment, okay, with different codomain. Therefore, it's not a function. Can I conclude? Let me link up the conclusion here. This is a relation, not a function. And this is the reason. One was repeated in the domain, but that one was assigned to different elements of the codomain. Assuming the elements of the codomain are the same, let's say this is 5, this is 5, then that could have been a function. All right, guys, we are done with this. Good evening, sir. Do you do online coaching for young kids in primary school? Yes, I do. And we have a special channel dedicated to our beloved younger scholars, those in basic class. But I coach those from basic 4, 5, 6, just as 1, 2, 3 on that channel. Then this particular channel, GMAETS 41, is for from SS1 down to university level. How can you get the channel dedicated for those in primary school? Just type GMAETS 41. GMAETS 41 together, basic class. Now in the basic class, you separate GMAETS 41 together, then space, basic, space, class. You have wonderful works for them, and I coach them through that place, step by step, because that level is very crucial. Once we start missing it from that level, that is when problems start coming. I read a comment here, someone saying that he hates math. You really don't need to hate math. Saying that alone, it's a problem. It's a problem. Maths itself is life, because it's from there you now have all this connection of physics, chemistry, and math help to improve your level of reasoning. For me, math is one of the most important brain developing subjects, and that's the truth. Don't argue it. Another thing is that all these calculation stuffs, to be honest, they are the most simplest. Something will come, somebody will just say 1 or 2 things before you know you start doing calculation. The calculation is based on a little foundation set out. So you want to love maths. Any challenge you have in maths, there are only 2 reasons for that. Number 1, your own perception yourself. Either you are scared or you're listening to some people who just wake up and they talk anyhow about this simple subject called maths. So that's one of the challenge, your own perception. Then number 2, perhaps the coach, the educator you have come across. Yeah, because I know some educators may make this thing look somehow, some way. I'm sorry to say that, but that's the truth. Especially these days that everybody wants to go into online teaching and other things. With the thought of, okay, we want to make it online, but let's not go there anyway. I encourage everybody to do their best. However, a good preparation to know how you can impart this knowledge, how you can deliver it. Because you see, there are a lot of academic creators. There are so many textbooks out there. We have schools littered everywhere with teachers, everywhere. By nature, everybody is a teacher even. But then, not all of us are out there to give that really, which will spike the interest of the scholars in key subjects. And this is the reason why the GMAETS 41 has taken it upon himself. If you check the way this channel is designed, take your time and go through this channel, especially go to the playlist. You'll notice that what is coming out from this channel is real course outline, scheme of work. I take my time to also arrange the playlist according to topics. If you visit a playlist on this channel, you'll be wowed at what you're going to see. So I am encouraging and urging you, please, quit using that statement that you hate maths. Love it. Maths is very important to life. Maths is life itself. Maths is simple. It is a function of the educator you meet. So as you come online, if maybe you feel that your school is not giving you what you expect, it could be a function of maybe the person educating you in that subject. Relax, that shouldn't make you to hate maths. You can still seek for further assistance. That is why technology has made life easy for us. Most of you don't know me. I don't know you, but we have connected through technology, making this world, this fair, a global village. You can interact with me. Do you know we can have certain level of conversation if need be? If you join us through this contact, you request for certain things that you want me to do for you. Of course, if you become a channel member, very important. I'm really saying that. Very important. And then, so please, can you work on this? Can you do this for us? And I will come on live on YouTube, do the work for you. And of course, the concept will be broken down 1 + 1. That's just one thing I assure you from this channel. So I'm encouraging all of you, please, 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 especially now for those of you that are, like Unizik, that I'm fully connected to because I run physical tutorials. They know me one-on-one. I know them. Then students I teach in Uni Abuja, other people from different parts of the country, in Nigeria, and from different parts of the world that connect to our classes. All you just have to do is to start your preparation in time. My students in Unizik, those in Uni Abuja, they are on break now. They just took their break, I think last week or so, first semester break, preparing for second semester. And what we are doing now is second semester work, learning without pressure. The class will soon end. 1 hour, 30 minutes, we are done. It's just that the concept of relations and functions is something you need to calm down and give, the background so that the students understand what we are really dealing with. In case we enter, especially the mathematical equation form of this topic, you understand really what you are dealing with. We'll talk about step function, we'll talk about asymptote, they will make sense to you. We'll talk about composite function. You will enjoy them based on the background knowledge. Start early on time. And then you will see gradually you are learning this thing, you are asking questions, you are taking time to analyze concepts. Go for math exam, don't be shocked. You can blast 100 over 100 if it's an over 100 exam. That is something that is very much possible with math, but you don't dare that easily with other subjects. I'm not saying you can't do that in other subjects, you can, but chances as compared to math will be low. While in math, if you understand it, it's very easy for you to blast all questions correctly. Anyway, I think I've encouraged you guys much. I've spoken much on that. So I coach all level of learning, I say from basic 4 to university level to 300 levels. It is now time for us to look at some past questions, please. I've got some questions here proposed by Unizik specifically, okay, Unizik past question, and I want to look at them. You can also send yours across to us from whichever school you are attending. Once you link up with us on WhatsApp, you can send us some of your own questions so that I can deal with them here. Is that okay? You explain very well and your voice is good for instructions. Thank you very much, Carol. Thank you very much. I'll continue to do my best, and all the glory and honor and praise will continue to go to our God and helper, Jehovah, who always makes this possible. All right, let's pick our very first question. Please, you can screenshot what is on the board so that I can wipe the stuff on the board. We just have some questions. This is already 1:29. I had wanted the class to stop by 1:30. So let us round off. Collins, you're saying you don't understand. I don't know when you joined the class. Perhaps when you joined the class could have been a factor. all right, that caused you, made you not to understand. But all the same, at the end of this class, a copy of this video lesson will be made available. Anytime GMAETS 41 is done with his live class, a copy of the live class is always made available so that any other person can take it anytime, any day, any year. All right, so you can check back on it. Check back. All right, this is our first question here. Which of the following relation is not a function? I'll dictate the question and then I'll write the options on the board. Question one. Which of the following relations is not a function? Which of the following relations is not a function? Then we have option A, 1, 1, 2, 2, 3, 3, 4, 4. Option B, 1, 2, 2, 2, 3, 2, 4, 2. Option C, 1, 3, 2, 3, 1, 4, 2, 4. Option D, 4, 1, 3, 2, 2, 3. So that's what we've got here. Once again, I'm going to read the question. Which of the following relations is not a function? So you see, all the options given to us here are relations. Remember I told you relation is open. You just combine both the domain and the codomain together. But which one of them, according to the question, is not a function? Which means that all the options here, these relations, all of them are functions except one. So which one of them is not a function? I gave you the secret already. You don't need to go start drawing this thing and then doing your linkage to know which. You don't need that. Which one is not a function? That's what they said. That's what the examiner asked. So quickly look at the first element in each of the coordinates. That first element are the elements in the domain. Look at a place where one of them is repeated. If you're able to locate the option where one of the domain elements is repeated, one of all the first elements of the coordinate you're seeing here is repeated, then hold on there, watch very well. That guy might not be a function. So I don't know if you've been following up with the class. Can you drop an option? William Collins, you dropped C. Let's look at C. Good. Good. I am not saying you are correct or wrong here, but I'm just saying good because immediately I took my eyes there, I saw that one was repeated. Yes, can I hear from any other person? Do you have a contrary option if you're still here? Williams Collins have selected option C, and I think I agree with him. If you look at option C here, this is 1, this is 1. This one you are seeing, all the first elements are elements of the domain. You have one here, you have one here, so it is repeated. A single element in the domain has been repeated in this condensed form. Now, check their codomain. You notice that the codomain you have here is what? 3, and the codomain here is what? 4. Different codomain. So it's just like saying one child, this one now, the same child having different parents is not possible. So the correct option is C. Option C is not a function. It is a relation, but not a function. The rest of them are functions. Little stone, right? Oh no, little one rather. So when you sit with I don't understand what you're saying, Little Stone. I don't understand that. What you're saying has nothing to do with this. Okay, let's move on to question number 2. These are real-time exam questions, guys. So in whichever school you are, if you are going to deal with relations and function in your semester work, Should be expecting questions of this kind also. So I've got this particular question. If, at least when I was teaching this concept, I showed you a situation where you have to substitute a particular value for x and get a corresponding value for y. So I can give you such type of question. Now let me copy out the question on the board. If f of x equals 3x minus 1 over x minus 2, comma, now determine f of minus 1 over 3. Determine f of minus 1 over 3. And we have the options here given. I'm going to list out the options on the board. Option A, 9 over 7. Option B, 6 over 4. Option C, 6 over 7. Option D, 4 over 9. Option E, none. Sometimes Unizik as a school will present that option as nota. That nota, N-O-T-A, means none of the above. Now, if f of x is equal to this function here, this function, determine the value of f of minus 3. This f of x is y. Remember in mathematics, we always write that y is equal to f of x. So that f of x can be replaced with y. So it's as good as we are looking for the value of y if x is equal to minus 1 over 3. Look at it. F of x is equal to this. F of x. And here the examiner is asking you to determine, find, evaluate f of minus 1 over 3. If you link it up to this, f, bracket, x, minus 1 over 3 inside the bracket, then close. So it is as simple as telling you that the value of x should be minus 1 over 3. So that you come to this function, wherever you see x, you fix minus 1 over 3. I guess this is going to be the second to the last question. Nothing is there in this subtopic under function. And of course, function generally is 1 plus 1. Let me tell you the truth. Calculus generally, I don't know what you think. But I'm telling you the basic truth. Calculus and many other topics and subjects, they are 1 plus 1. It's just about you understanding this. And if the background, the foundation is set out for you, you can explode from there. Expand, build up on that unique foundation that has been built. I've always told students, a building cannot stand without the foundation. So do not joke with the foundation of anything. It's not all about rushing to go into soft questions. No, the foundation is the most important. Once you grasp the foundation of something, even you on your own can expound on that thing beyond your educator, beyond your teacher. It's possible. Leave that thing that is said that someone cannot be better than his teacher. That applies only to God in Jesus Christ. Humanly, a student well taught in time, can be better than his teacher. Is it not just all about personal research? Work further. So when it comes to human relationship, a teacher can be better, a student over time can be better than his teacher. Okay? And so if you work on your foundation very well, these things would be 1 plus 1 for you. So f of x is this function. Now find f of minus 1 over 3. It means that x is equal to minus 1 over 3. Solution, x is equal to minus 1 over 3. It implies that f of minus 1 over 3 will be equal to, go to this function, wherever you see x, like I fixed f minus 1 over 3. Come over here, this is going to be 3 times, in place of this x, you fix 1 over 3. You fix minus 1 over 3 rather. Let me use blue shade of marker to fix up those things for you at least. So where is this? Minus 1 over 3. So this is going to be 3 times minus 1 over 3. All right. Then you know that after this x, you see minus. And what you have there is 1. We're going to divide this by x. The value of x is 1 over 3. And then after this x, you have minus. Then half. Oh no, that's 2, not half. So I'm going to simplify this and I'm going to be fast. If you still have any challenge with basic arithmetics, For those who say they hate maths or whatever, don't hate it, please. Love it for my sake. For my sake. Is that okay? If you follow up with the GMAS 41's classes and you allow me to coach you from wherever you are, you will love maths. But the truth of the matter is, I will not respect your level. Anybody that hates maths, I will take that person first to basic maths, which you learn that from GMAS 41's basic class channel, because you need to start from certain things there. First, to talk about the concept of numbers and numeration. It can be funny, not those place values. What I'm saying can be funny, but you have no choice. That's the truth. You have a challenge, you have a problem, we have to find a way to solve it. And if you are humble enough, following a good coach, the advice of that good coach, of course, you just need like 3 months, at least at this age you are. You need like 3 months to pick up. After that number and numeration, all those place values, then you move on to the concept of basic arithmetic, addition, subtraction, multiplication, and division. Once you are able to hit division, you understand these 2 basic topics very well. Numbers and numeration, basic arithmetic, which include plus, minus, times, divide, then a little touch of fraction. Your problem in calculation is solved. So if you have any challenge with basic maths, please can indicate. You send a message to me, discuss with me, I will guide you on what to do. Let's round off this. This 3 will cancel out this 3. 3 divided by 3 will give you 1. So minus 1 times 1 will give you minus 1 divided by minus 1. Because if the 3 is, that thing will say cancel out. Hey, it's not as if the 2 will just cancel like that. This thing means 3 divided by 3. Here will be 1, here will be 1. That's the implication. So you'll be left with minus 1 here. Minus 1 will give you minus 2. Are you following, right? We'll give you minus 2. So that minus 2 will now be minus 1 all over. Oh no. This is minus 1, then minus 1. Minus 1 will give you minus 2. Come over here. This is 1 over 3 minus 2. You work it out using LCM. The fastest way of handling LCM of a fraction and a whole number is to use the denominator to multiply the whole number, then add or subtract from whatever I have in the numerator. That's going to be 3 times 2, which is 6. That 6 will be in the numerator now. Then now have 1 minus that 6. This is minus 2. The 2 is on top. Numerator, you know. 3 times 2 will give you 6. 1 minus 6 will give you minus 5. Minus 5 all over 3 is what you're going to have in the denominator. Minus 5 over 3. So mathematically, from what we have here, the 3 will now go up. Mathematically, from what you have here, 3 will move up. If 3 moves up, it will multiply that minus 2. 3 times minus 2 will give you minus 6. Of course, the negatives will cancel out anyway, so you have 6 over 5. So that's the value of f of... I think there is a slight mistake here. Sorry about that. I didn't fix minus here. I didn't fix minus for that value of x. No, the value of x, BS minus, please. So this is minus. Good. I'm sorry for that error. So that gives us the numerator is negative 2. Then quickly, this times this is minus 6. Minus 1 minus 6 is going to give us minus 7 all over 3. This 3 will go up. The negatives will cancel out. And if the 3 goes up, it will multiply this. That's division of fraction. And then you have 6 all over 7. That's the value of f of minus 1 over 3. And clearly you see that from here, the correct option is option what? C. You don't need to stress yourself through all these things. With your good knowledge of basic arithmetic, like I said, from the GMAS 41's the basic class channel. At the end of the class, search for that channel, subscribe also, so that whenever I'm coaching those in basic class, you can follow through also. If you have any challenge with basic arithmetics, to follow through all these things, to know what happens from GMAS 41, join our WhatsApp group. Send a message to this contact, all right, on WhatsApp. Like I said, if you're sending a message, your name, your full name, where you are contacting us from, the level of learning, very important. With your good basic arithmetic knowledge, you could have just been looking at this and simplifying. Fix minus 1 over 3 here. That 3 will cancel this 3. You'll be left with minus 1, then minus 1, giving you minus 2 quickly. Then fix minus 1 over 3 here. Work out the LCM. 3 times this 2 will give you 6. Minus 1 minus the 6 will give you minus 7 all over the 3. 3 will move up to multiply that minus 2. You have minus 6 on top, all over minus 7 under. 7 will cancel out. You have 6 over 7. So we are done with this particular question. That's good. William Collins. That's good. Yeah, you forgot the negative sign for the button. Thank you very much for that wonderful observation. All right. You're doing well. So that is that for this question, please. Finish up. Let's take our last question. We have overspent our time. We have overspent our time. Yes. The time that I intended. So I'm wiping this. I've told you to be fast sometimes. You can screenshot. So the question we have, I won't copy the question. I'll just give the option. Question 3. In question 3, it's just like the first question. Which of the following relations is a function? Which of the following relations is a function? Option A, comma A comma B. Option B, A comma B, and then C comma B. Option D, no, option C rather. B comma D, and then B comma minus D. I hope you are seeing the coordinates as they are being provided. Sometimes the examiner can put this in brace brackets. Normally, by standard, it is meant to be enclosed in brace bracket anyway. Or sometimes in all these questions, we neglect those simple but clear-cut rules. So, which of the following, according to the question, is a function? It means all the options given here, only one of them is a function. All of them is not a function except one. That's the meaning of the question. I read it again. Which of the following relations is a function? All of them are relations, but only one is a function. So what you have to do is to check for the one that is a function. And that one that is a function, no domain value will be repeated. Let's look at option A. You notice that there is a repetition here. So this is not a function because the domain here repeated here with different parents. If you look at this, the domain was not repeated. The domain here is A, the domain here is C, different domain. Good. Linking us to something close to function. We'll now check the codomain. Are the codomains different? If the codomain elements are different, then we'll now say, good, this is a function. And I think clearly you see, the codomains must not be different, rather. The codomains must not be different. The codomain may or may not be different. I think when I was highlighting this, there was that question I told you, assuming that guy was, I think, 5'5", it could have been a function. So please, sorry about that. And you also remember I told you something about constant function, where all the elements from the domain will be assigned, will be mapped, and they'll be linked to only one element in the codomain. So here we have the what? Different elements of the domain. Then you notice the codomain is different. The codomain is the same. No problem. The codomains may or may not be the same. They may be the same, they may not be the same. No problem. You don't have any issues with that. Okay? Remember, a father or a mother can give birth to more than 2 children or 1 child. That's just the idea. So this is the correct answer. This is the function. This is the function. The key thing is just to look at the domain. The domain. There must be different elements. The codomain is not a problem. The codomain may be the same element or different element. This one is not a function. You can see it clearly. The same element of the domain repeated. But then look at the codomain. The codomain differs. That's a different parent said to have the same, giving birth to the same child is not done. It's not possible. So this is not a function. This is not a function. The correct function is B. So the relation in the question given, that the relation that is a function is B. All right, we are done with this, and I guess we want to put it to a close. But let me leave you with this question. Let me leave you with this question. Can work on it. Drop the answer in the comment section of this video lesson at the end of the class. Because right now, anything you type in the live class will disappear at the end of the class. So I want to give you an assignment. I'll copy the question on the board. Assignment. You will type your answer in the comment box below this live class at the end of this live session. If you type your answer now, like I said, it will disappear at the end of it. So this is the question. Determine the domain and range of the function. I've explained the concept of domain, codomain, image, and range. I've explained it. And there was something we found out. It's possible for the range to be the same as a codomain. It is possible. Where all the elements in the codomain is an image of an element in the domain. In that case, the domain and the codomain, they are the same. In that case, the codomain and the range will be the same. We concluded that the range is an improper subset of the codomain, where all the elements in the codomain is an image. Then the range will be the same exactly as the codomain. And maybe like on that set, we can conclude that the range is improper subset of the codomain. All right, so option A, determine the domain and range of the function. So we have option A, and range of the function. Now this is the function first. This is the function first. 1, 2, 3, 5, minus 1, 17, 5, minus 3. So this is the function. You are required to determine the domain and the range of the function. In fact, I am going to add my own question. Find the codomain also and list the image of the function. So find all the 4. Domain, in fact, let me add it up. I don't have space now. I'm already reading this. But please include the image and the range of this function. But the options I'm going to give to you will just be in line with this domain and range. Now option A, 1, 3, minus 1, 5. And 2, 3, minus 1, minus 3. So this domain, this range, that's what the option provided. Option B, 1, 3, minus 1, 5. I know we have passed 1 hour 30 minutes I wanted us to spend, but all the same, that is why I don't want you guys to be coming up online here to be making certain requests. I don't understand where it's coming from. I think your request should be based on the topic we are dealing with. If you need anything, join our WhatsApp group so that before anything or any class, you can indicate what you really want us to do for you, what you want GMAETS 41 to handle for you. Don't come here and make me to talk too much advising you. I'm going to stop that from next class. Just I don't want any one of you to feel left out or neglected. That's why sometimes I see some comments, I will still respond to it. Become a channel member. Send a message to this contact on the board. Request to be added to the WhatsApp group. To become a channel member, please join the GMAETS 41's platinum or diamond level. The platinum level goes on 2,000 naira monthly. Just imagine 2,000 for a whole month. But depending on what is convenient for you, you might choose to go further. If you support GMAETS 41 more on diamond level, that will be much more appreciated. 1, 3, and then we have -1, 5, and 2, 5, 17, and 3. Then the last option E, 1, 3, -1, 5, and 2, 17, -3. So that's the question, right? Now, I'm going to indicate drop your answer, drop your answer in the comment box, below this video. Also, NB, state the image or list the image, and the range, and quote the range of the above function. Just as a hint or a reminder, image is not a set, range is a set. So I'll be reading through your comment, your answer in the comment box of this video. If you're a channel member and you answer correctly, if you are a channel member and you answer correctly, you are going to win airtime, 500 unit airtime. Remember, if you are a channel member and you answer this question correctly, the first two to answer this question correctly are going to win. They'll be gifted 500 unit airtime each. Don't come and tell me, or maybe feel it, why did I say channel member? Yes, anything I give out must be to the GMAETS 41's channel member. There are still a lot more coming for them. Like I said, there is an announcement I'm going to make by God's willing before this week ends. The student that makes it to the GMAETS 41's Hall of Fame, this set, a wonderful package is coming his or her way. You must appreciate and support GMAETS 41 to benefit fully, to gain access to the benefit meant for channel members alone. All right, guys, thank you for tuning into the class, and I hope you learned something very well from the class. Share the links to your friend, invite them to subscribe to this channel. If you have not subscribed already, please kindly do so. Turn on the notification bell so that whenever I upload any content, you will be personally notified. In our next class, in Math 101, we shall be dealing with the concept of domain, purely domain. Can be given mathematical equation. I can tell you, find the domain of 2x minus 5 all over x plus 1. What is the domain of that function? I can ask you, given f of x equal to square root of x squared plus 5x plus 6. Find the domain of the function. How do you deal with such question? So in our next math class, I'm going to deal with that. However, remember that in our next class, really will not likely be dealing with maths. I don't know. I am thinking we're going to look at Chem 102, organic chemistry, IUPAC nomenclature. But all said and done, I'll decide before Wednesday, because the next class is going to be on Wednesday. Tomorrow, I'll be having a live class on electricity, electrostatics. Yes, for JAM students and WAEC students. That electrostatic is also useful to you guys. Yeah, I know those in Unizik, you're going to be dealing with electrostatics, electricity, magnetism, and light in your phase 102 next semester. do well to connect to the class. To know how the class is going to run everything, request to join our WhatsApp group. Our next class is going to be on Wednesday. You'll get information on the course we are going to deal with for advanced level. Like I said, tomorrow's class is going to be meant for JAM and WAEC students, but it's also applicable to you guys in advanced level also. You can connect to the class. Good night and take care of yourself. So is constant function same as one-to-one function? No. No, it's not the same. It's not the same. Then constant function is onto function. It's just onto function. Like I said, that's not what we discuss in this class, okay? Don't worry, calm down. We are coming to all these things. We can't learn all of them in one day. And I don't want to rush you guys unnecessarily. We are not preparing for any exam for now. I can't remember that, right? Okay, bye. See you tomorrow or Wednesday. Tomorrow for JAM and WAEC class, we're dealing with physics, going to study electrostatics. The GMAETS for the ones WAEC and JAM students have dropped the questions. We're going to deal with so many of them. And of course, for advanced level, I'm meeting you once again on Wednesday, like I said. You get to know about the course we'll take that Wednesday. I'll drop the information in our WhatsApp group.